A very good day. My name is Dr. Sylvester from Group 7, and today we are going to present our business project proposal regarding the restoration of aerotrain operations at KLIA. Here are the group members of Group 7, which consists of 5 individuals, which is firstly me, Dr. Sylvester, Philbert Jonal, Nadra binti Joffrey, Sammy Chung, and finally Protesius Javier. Firstly, we are going to discuss about the project planning, and the problem statement for this project is that on March 1st, a serious incident occurred at KLIA where an aerotrain broke down midway between terminals. A second train was sent to assist, also failed, which leads to MHB suspending the entire aerotrain service. The issue was traced to a circuit breaker failure, which reflects the aging infrastructure, which is the current system is over 25 years old and has become increasingly unreliable. To manage the disruption, temporary shuttle buses were deployed, but these are limited in capacity and not as efficient. The breakdown sparked public concerns over safety, reliability, and the airport's international reputation. So, this project was initiated to urgently reassess and modernize the aerotrain system using a structured project management approach. So our goal is to restore public confidence and to ensure a safe, seamless transit experience at KLIA. Next, as for the objective, firstly, this project aims to establish a structured cost management plan to guide repair efforts for the aerotrain system. Secondly, we are focused on resuming train operation as soon as possible to minimize inconvenience for passengers. Thirdly, we will appoint a dedicated project team to investigate and resolve the technical issues that caused the disruption. And finally, we will carry out all the repair work according to strict protocols, ensuring the system's long-term reliability and safety. So here is the work breakdown structure of the KLIA rectification project. So there are a few crucial parts in the work breakdown structure where we need initial assessment and diagnostic, repair operation, testing and validation, as well as restart and maintenance planning. This is the organizational chart for this project. So under Malaysia Airport Holding Berhad, MHB, there are project director, project manager, finance and human resource. Other than that, engineering manager, quality manager, stakeholder communication manager, and logistic and operation manager will work together to ensure a seamless flow of the project rectification. This project is not just a technical upgrade, but it also brings a real social and ethical responsibility. During the repair phase, passengers, especially the elderly, disabled and those in transit may face longer walking distances and crowded shuttle services, which can lead to discomfort and dissatisfaction. And at the same time, airport staff may experience temporary role changes. To manage this well, clear communication and proper training are essential to support them through the transition. From the ethical standpoint, we must restore public trust that was affected by previous delays. Transparency in sharing, progress, costs, and timelines is key to demonstrating accountability. And from an environmental standpoint, we must adopt sustainable practices, which is to minimize emission and managing waste responsibly during construction. Now, we are going to discuss about project scheduling and the necessary activities for this project. So, to ensure the successful restoration of the KLIA aerotrain service, the project is structured into 6 critical stages. So, we begin with preliminary activities, including needs assessment, stakeholder identification, and site inspection. This is followed by planning, where we develop a detailed work breakdown structure, allocate resources, and establish risk and communication plans. Next comes the technical phase, which focuses on inspecting existing systems and designing necessary upgrades. Once that's set, we move into implementation, which is to mobilize contractors and installing key infrastructure like new trains and automated system. After that, we conduct testing and commissioning to ensure the upgraded system meets safety and performance standards, while also training the staff. Finally, we reach the final stage, which is the inspection and approval stage, where regulatory audits are completed, the system is certified, and operations are officially handed back to MHB for public relaunch. As for the activities details and time estimation, we use Gantt chart. There are 2 types of Gantt chart, namely the early start, early finish, which is on the left side, and the late start, late finish, which is on the right side. From the Gantt chart, we can observe that phase 1, it consumes 4 weeks, while phase 2 consumes 9 weeks, which is the most weeks consumed out of all 4 phases. Next, phase 3 consumes around 6 weeks, and finally the phase 4 consumes 5 weeks. Overall, the whole project rectification of KLIA requires about 21 weeks to reach its completion stage. Based on the Gantt chart, This table outlines the project phases and activities for the KLIA Aerotrain Service Improvement Project. The work is structured into 4 main phases, starting with initial project planning, which includes stakeholder identification, planning, and budget approval within the first 4 weeks. Next, the mid-project assessment spans weeks 4 to 12, which covers repair planning, sourcing materials, and conducting the actual repair works. This is followed by safety inspection, which involves safety checks, trial runs, and performance reviews from week 12 to 17. Finally, the finalization and approval phase ensures quality control, ongoing monitoring, and proper project closure, which concluding by week 21. Now, as for the final part of the project scheduling, we need to identify the potential scheduling risk. One major risk lies in the technical and design phase, where issues like delayed approvals or mismatches between designs and actual conditions can lead to rework and idle resources. So, to prevent this, early stages technical, workshops, and cross-discipline coordinations are essential. Next, procurement risk, particularly for imported components like control units, which can severely impact timelines due to supply chains disruption. Therefore, we recommend early ordering for critical parts, buffer stock planning, and selecting reliable vendors. Lastly, scope changes, either from client input or unforeseen site conditions, which can have ripple effects across the entire schedule. To control this, a structured change management system is needed, requiring proper justification and formal approval before adjustments are made.
So, I will be presenting the project controlling part. The objective is ensure smooth, cost-effective, and timely restoration of the train operation. It focuses on robust project controlling to manage performance, cost, schedule, risk, and also feedback. It has 7 highlighted critical subtopics, and we will jump straight to the first subtopic. Okay, in performance monitoring and progress tracking, firstly, knowing the status of all time is essential. Real-time tracking will be used, defining clear key performance indicator or KPIs for train system performance and maintenance quality. Earned value management will objectively assess progress and value. A live dashboard will provide instant update complemented by regular reviews, meeting to discuss completed tasks, identify bottleneck, and quickly adjust strategy to stay on the course. Financially, preventing budget overrun is crucial. To manage this, the cost variance strategy involves continuous tracking using the cost variance index. Regular budget check will also ensure every cost match with the approved budget. If difference occur, root cause analysis will determine why they happen, thus allowing for the implementation of smart way to save money, such as in negotiation for better supply deals to maintain financial health. Avoiding delay is vital for the critical infrastructure. Therefore, schedule control is designed for its accuracy. The critical path method will identify essential activities that directly impact project completion time, which ensure effort are focused effectively. The schedule performance index will constantly track progress against the initial plan. Additionally, extra time for unexpected events will build in, and smooth teamwork among all teams will prevent holdups, ensuring continuous forward movement. In the project of this scale, it's important to expect that could be gone wrong. Key potential risks identified include technical issues in train system or infrastructure, along with the supply chain problem for the important part. There are also challenges in meeting the circumvention rule and possible money problem. Understanding these risks allows quick action, which help avoid big problem with the work. Knowing the risks is only part of it. Having solid plan to deal with them is the key. The strategy includes stopping problem before they start through regular check and strong quality rules. Furthermore, backup supply will be established to ensure material are always available, and insurance coverage will be considered for financial protection. A delicate team will also ready to handle any emergencies. This measure ensure the project remains strong even when facing unexpected challenge. Monitoring will be structured across 4 key areas to keep close eye on everything. For resource monitoring, how well the team is working and inventory level is tracking. In cost monitoring, regular money check will be done and future spending will be estimated. Quality monitoring involves using total quality management and regularly check to keep a high standard. For time monitoring, computer program with track tasks, frequent review will ensure a good output. This careful way of checking everything guarantee efficiency across every part of the project. Always getting better is the central of this approach. The feedback system is designed to be quick and helpful. Regular meeting with key people will be held to check progress and discuss problem. Ideas will be also gathered directly from the engineering team and workers on the ground through survey. After the train restoration, careful check will be done to see how the things went, and lesson learned will be carefully written down to help future project. This process ensure constant learning and adaptation.
Thank you, Philbert. Now I'm going to present regarding the possible problems that may occur during the project. In managing the repair and reactivation of the train system, several potential quality issues must be anticipated and addressed to ensure project success. One major concern is inadequate repair quality, where poor workmanship may lead to system failures or rework, affecting safety and timelines. Another issue is the use of defective or outdated components, which can compromise system efficiency and reliability. Additionally, non-compliance with safety standards poses legal and operational risks, potentially endangering workers and passengers. Project delays may occur due to inspection failures, unexpected technical issues, or delays in part procurement. In identifying these risks, allows the team to implement preventive measures and maintain control over quality and schedule. A structured quality management and inspection process will be essential in reducing these risks and ensuring the train system is restored to safe and reliable operation. Next is the quality control. To ensure high standard during the train system repair, a structured quality control process will be implemented. It begins with incoming inspection of all spare parts and materials to verify compliance with technical specification. These steps helps prevent substandard components from entering the system. During repairs, in-process inspection will be conducted at key checkpoints to monitor progress and detect any deviation early. Once the repair are complete, a final inspection and functional testing phase will be carried out to validate performance and safety. To further enhance reliability, a third-party certification will be obtained from an accredited body, adding credibility to the entire process. These layers of inspection ensure that every repair meets industry standards, reduces risk of failure, and builds stakeholder confidence. The goal is to deliver a train system that is not only functional, but also dependable and safe for public use. Next, I would like to talk about quality improvement strategy. To ensure long-term success, a proactive quality improvement strategy will be applied throughout the train system repair project. This begins with root cause analysis, RCA, to identify the underlying reason for defects or failures, enabling target and effective solution. Following RCA, corrective and preventive action, CAPA, will be implemented to eliminate issue and prevent recurrence. The team will also adopt Kaizen principles, which encouraging continuous in a small-scale improvements by involving all personnel. A feedback loop system will be established to collect quality data, analyze trends, and make real-time decisions for ongoing enhancement. This continuous improvement cycle not only raises performance and reliability, but also reduces cost and downtime. By embedding quality into every process and promoting active involvement, the strategy ensures the train system is restored and maintained at the highest standards. Furthermore, I'm going to talk regarding about the total quality management, TQM. Total quality management is a management philosophy that emphasizes continuous improvement in all aspects of a business, involving all employees in achieving customer satisfaction and quality excellence. TQM involves all team members, encouraging participation and accountability at every level. Through continuous improvement, small consistent enhancements are made to process and outcomes. The approach is process focused, meaning quality is built into every phase, from inspection to commissioning. TQM also promotes data-driven decision-making, which using results from testing and inspection to guide improvement. By fostering a culture of excellence, collaboration, and transparency, TQM also helps in ensures the project meets both technical standards and stakeholder expectations, while also enhancing efficiency and reducing errors. This philosophy is essential to delivering a high-performing and dependable train system. To enhance the efficiency, safety, and reliability of the train system repair, the project will adopt modern technologies. Predictive maintenance using IoT sensors will monitor component condition in real time, helping detect issues before failure occurs. A digital twin will simulate system operations virtually, allowing engineers to test solutions before implementing them physically. A computerized maintenance management system, CMMS, will be used to track and manage all repair and inspection activities, improving organization and compliance. Drone technology will assist in inspecting hard-to-reach areas safely and efficiently. These tools not only improve precision and reduce human error, but also speed up the repair process and support informed decision making. The integration of these advanced technologies ensures the project remains future-ready, cost-effective, and capable of meeting the highest quality and safety standards. The layout strategy for the train system repair will follow a process-oriented design, grouping tasks based on similar functions like mechanical, electrical, and inspection work. This ensures efficiency and minimize unnecessary movement. Strategic equipment placement will ensure tools and diagnostic stations are close to their respective work zones, enhancing accessibility and reducing downtime. Safety is a top priority with clear emergency exits, first aid stations, and well-defined safety zones integrated into the layout. Regulatory compliance with safety standards like OSHA and fire codes will be maintained, ensuring the workspace is safe and comfortable. The layout will also be flexible, allowing adjustment as the project progresses. Overall, this layout design maximizes workflow efficiency, reduce risk, and ensure high standard of safety and quality throughout the repair and reactivation phases. Next, I will pass this to Semi.
Thank you, Nadra. Allow me to introduce myself. My name is Semi Chung Susan with matric number speaker 2110219. And after this, I'm going to talk about the human resource strategy, where we have few points. And the first point is relevant strategy. In this strategy, the human resource strategy aligns staffing with project milestones, where it is ensuring the right expertise is available at the right time. And then they will focus areas include upskilling current staff and recruiting specialists to meet technical demands with HR and project teams working collaboratively to sustain performance. And for the second point is workforce planning, where the workforce planning involves analyzing skill requirements across all project phases. Gap analysis and collaboration with training institution ensure the availability of qualified personnel and prepare for any staffing shortage. And for the point, which is the work schedule development, where the schedule are developed using Gantt chart and project management tools. And the shift-based planning and flexibility help prevent fatigue and ensure the compliance with labor law while supporting efficient progress. And then for the job and work rules classification, where the job roles are clearly characterized by responsibilities and required qualification, where the work rules are based on engineering safety standards and labor regulation, and also the supporting discipline, flexibility, and the employee motivation. And the next point is the work method analysis, where the work processes are analyzed using time and motion studies to remove the inefficiencies. And the standardized procedures and continuous improvement methods, such as Kaizen, are used to enhance the productivity and reduce the delays. For the next one is the performance assessment, where the performance is evaluated by using KPIs is tailored to roles, where, for example, is task accuracy and safety compliance. In the regular review, identify the training needs and reward high performing staff to improve project outcomes. And the next point is about the health, safety, and environment, which is HSE. The strict HSE policies are enforced, including PPE use, which is personal protective equipment, and the safety training and emergency drills, where the environmental controls are applied to reduce the noise, dust, and the waste in accordance with airport and national standards. For the last point, which is the feedback mechanism. And the structured feedback is collected through the surveys and meetings to identify issues and suggest the improvements. Then this foster open communication, build the trust, and drives the continuous improvement. So after this, I'm going to talk about the supply chain management, where the first point is about the supply chain decisions, where the centralized procurement is chosen to reduce the cost and ensure the quality control. The critical components are outsourced to OEMs, while simple assemblies are produced in-house, it depending on the cost, lead time, and the complexity. After this is about the sourcing strategy. A multiple and local sourcing strategy minimizes the disruption risk and supports the local suppliers. Like the long-term contracts and the performance incentives strengthen the supplier relationship and the reliability. And the next point is about the risk management, where a risk matrix is used to identify the supply chain threats like the delays or the cost fluctuations. The contingency plans include the safety stock, alternate vendors, and the contractual safeguards. For the next point is about the logistic efficiency, where JIT, it is just-in-time delivery, is used for non-critical items with the buffer time included for essential parts. The GPS and RFID tracking ensure the real-time visibility and the coordination within the airport environment. And the next is about inventory management, where the inventory is managed using ABC classification and EOQ calculation to balance the stock levels and reduce excess. Like the cycle counting and the reorder point system maintain accuracy and the availability. The next one is about the automation and technology, where the ERP system and warehouse technologies automate procurement and inventory processes. Tools like RFID and barcoding enhance accuracy and tracking the efficiency. Then the supply chain assessment, where the performance is monitored using SCOR metrics such as delivery reliability, cost, and responsiveness. The supplier evaluation and the corrective action plans ensure the alignment with project goals. For the last point is about the waste management, where the waste is characterized, segregated, and disposed of according to regulation. Clean practices minimize unnecessary material and promote a clean, environmentally responsible worksite. That's all from me. Thank you.
Hello, my name is Potasis Mukyao. My matrix number is PK22110118, and I will be presenting my section on maintenance and reliability. So the definition is maintenance and reliability involves keeping machinery, equipment, and facilities in good working condition to ensure they operate consistently and without failure over time. To ensure that the KLIA aerotrain runs consistently, it is essential to prioritize the condition and performance of the aerotrain. Failing to do so can lead to delays at best, or at worst, serious accident caused by malfunctioning of the train. Before we begin formulating a strategy, we must first lay out the criteria for what appropriate reliability is. The maintenance strategy should include a predictive element in them due to the fact that there are frequent delays caused by the technical difficulty, and these delays are disruptive because the component failures being unpredictable. So, in order to circumvent these issues, the maintenance must include a predictive element as to make it easier to schedule a time to maintain and service them, as well as to not disrupt the schedule for the passengers. I will now be talking about the impact of maintenance. So there are three main strategies that we can employ and implement, which are breakdown maintenance, preventative maintenance, and predictive maintenance. Breakdown maintenance is the act of repairing after the equipment has become faulty and thus is in need of repair. This strategy has the lowest initial cost due to not needing a schedule or dedicated staff to organize the maintenance. Since the maintenance is reactionary in nature, this increases the risk of unexpected downtime, as well as long-term costs increase due to needing frequent repairs and component changes. The next maintenance I will be discussing is preventative maintenance. Preventative maintenance involves regularly servicing equipment to reduce the risk of unexpected failure. By regularly servicing the equipment, the risk of unplanned downtime is reduced significantly, as well as increasing the longevity of the equipment. Although this requires more upfront investment in the form of skilled staff and tools, which can lead to increase in costs. Lastly, predictive maintenance. Predictive maintenance involves monitoring the condition of the component using specialized tools to determine exactly when maintenance should be performed based on the condition of the component. By knowing the trends and likelihood of failure, unplanned downtime is minimized significantly. Through the use of real-time data, the scheduling can be optimized to ensure that no disruption in scheduling can occur. Although the strategy is good, it does have a high initial cost in sensors, software, and trained personnel to use the software. Next, I will be discussing about cost-benefit analysis. For breakdown maintenance, by implementing it, there is a low upfront cost due to not needing dedicated staff or a planned schedule of when we can do the maintenance. But in exchange for that, there's a high long-term risk of unplanned downtime and emergency repairs due to maintenance commencing only when failure occurs. So, with those information, it is best that this maintenance is implemented for non-critical components. Next is the preventative maintenance. For preventative maintenance, through service of the equipment will have an extended lifespan, which will in turn will be good for the long-term cost of this equipment and the organization. It's best for ongoing maintenance of the equipment that are still in use, as well as those that are in need of part replacement. Lastly, for predictive maintenance, through the use of data analysis and sensors, failure can be determined with strong certainty, and thus in the short term can save costs due to maintenance only occurring when failure of equipment is close, as well as maximizing the longevity of the equipment in the long run. But the high initial investment does make it hard to implement, so it is best only for critical equipment that are very important to the operation. I will now be discussing about system reliability. While this might seem cost-effective initially, it comes with a serious downside: low reliability, as well as the highest risk of system failure due to allowing the components to run until they malfunction. We increase the likelihood of unexpected breakdown, leading to operational disruption, costly repairs, and loss of productivity. The second one would be preventative maintenance, which is a proactive strategy that involves servicing a component at scheduled interval. This helps reduce the likelihood of failure before it happens, offering a more reliable system compared to breakdown maintenance. However, it's not perfect. Issues can still arise between maintenance cycles, leaving room for potential disruptions. Lastly, predictive maintenance. This method relies on continuous monitoring of systems and components, using data to detect potential problems before they turn into failures. By identifying early warning signs, predictive maintenance can minimize downtime, enhance safety, and ensure consistent performance, especially critical systems like train operation. I will now be discussing about integration of technology. By incorporating advanced tools and techniques, we can improve the significance, the effectiveness of maintenance strategy in industries where equipment reliability is key. By identifying the problems before they lead to failure, we can prevent all of this issue. The three diagnostic methods I will be discussing are vibration analysis, infrared thermography, and oil analysis. Now, for vibration analysis, every machine has a normal vibration pattern. When the rhythm changes, it can indicate an issue such as imbalance, misalignment, loose components, or bearing wear. By continuously monitoring vibration, especially in critical components like engine, pistons, maintenance teams can spot early signs of failure and prevent major breakdowns before they happen. This approach drastically reduces unexpected downtime and costly repairs. Next, infrared thermography. By using tools like thermal imaging cameras to detect heat emissions from components, this will allow us to visualize temperature difference on surfaces like engine parts, electrical panels, and mechanical systems. Help identify overheating components like loose electrical connection and insulation breakdown. Best part? It's non-contact, so it can be performed while the equipment is running, making it both safe and efficient for failure detection. Finally, oil analysis. This technique involves testing oil sample from the train engine to check for contamination, degradation, or internal wear. The presence of metal particles, water, or dirt in oil can be an early warning sign of component deterioration or poor lubrication. Issues that might not be visible from the outside. Regular oil testing ensures that the engine operates at peak efficiency and remains in top condition over time. So for the maintenance suggestion, the best approach would be a mixture of predictive and preventative maintenance. The predictive maintenance is for critical parts like the engine of the train, as to ensure that it is always reliable and prevents any unexpected failures. Next, preventative maintenance for non-critical parts, so that it can maintain its overall condition as well as the quality. This combination reduces unexpected breakdowns, extends the lifespan, and improves passenger experience while balancing costs and performance. Now I will be presenting work order management. Work order management system is a vital tool that helps organization plan, assign, track, and complete tasks efficiently. It ensures that activities are properly documented and executed, contributing to better asset performance and operational reliability. Now, for the maintenance, for breakdown maintenance, since it's a reactive system, it generates work order after failure occurs. This isn't very efficient due to tasks having no plan and thus needing extra time to properly assess the situation as well as sudden resource allocation. Now, for prevention maintenance, because it works on schedule system, the work can be easily planned in an easy predefined interval. This allows for better planning of labor, allocation of parts, and equipment. Finally, for predictive maintenance, by integrating with real-time monitoring, work orders are triggered based on performance data. Because failure are easily tracked with certainty, this improves efficiency due to planning as well as minimize unnecessary maintenance. Now, in conclusion, the KLIA Aerotrain Restoration Project represents a carefully planned and technically sophisticated endeavor aimed at revitalizing the airport's automated rail system to ensure safe, efficient, and reliable transportation. Every aspect, from the maintenance strategy, supply chain coordination to safety compliance and technology integration, has been strategically designed to minimize disruption while enhancing the operational longevity. The chosen methodologies such as predictive and preventative maintenance, modern diagnostic tools, and robust workforce planning contribute to an optimized future-ready transit system. By addressing and implementing these recommendations, KLIA will not only achieve a successful restoration, but also a sustainable, high-performance automated rail system that delivers long-term operational excellency and passenger satisfaction.